We're going to look at lesson 22 and 23 problem set. So this is lesson 22. It says it at the top. Lesson 22 also says Monday. So it says solve for the unknown, rewrite each phrase as a multiplication sentence, circle the scaling factor, and put a box around the number of meters. So the scaling factor is 1/2. So it said circle the scaling factor, put a box around the number of meters. Doot, doot. So 1/2 times 8 is 8 halves, which is the same thing as 4. 8 is our scaling factor. 1/2 is our number of meters. 8 times 1/2 is still 4. The difference is what happened to our number of meters. Here, my number of meters decreased because my scaling factor was less than 1. Here, my number of meters increased because my scaling factor was greater than 1. All right, we're skipping number 2 and we're going to number 3. Fill in the blank with a numerator or denominator to make the number sentence true. 7 times something has to be less than 7. I want it to be less than this 7. In order to be less than this 7, my scaling factor has to be less than 1. So I can put 1/4, 2/4, or 3/4. That's the only thing I can put. 1/4, 2/4, or 3/4. So you can put a 1, a 2, or a 3. All right. 7 times 15 is greater than 15. I want it to be greater than 15. So my scaling factor has to be greater than 1. It has to be greater than 1. So in order to make this greater than 1, I can put a 1, 2, 3, 4, 5, or a 6. I can't put 7 because 7 sevens is exactly 1. But anything that's greater than 1, any improper fraction here will work. So I'm going to put 7/1. 3 times something is equal to 3. I want it to be equal to 3. So my scaling factor has to be equal to 1. The only thing I can put here is 5. 5/5 is the only thing. On A and B, I had different options I could put, but on letter C, I can only put 5/5 because it has to be equal to 1. All right, look at the inequalities in each box. Choose a single fraction to write in all 3 blanks that would make all 3 number sentences true. Explain how you know. So, if I look, my sign is greater, greater, greater. So in order to make this greater than 2/4, this greater than 2, and this greater than 7/5, my scaling factor has to be greater than 1. Any improper fraction or any whole number would work. So I'm just going to use, 5. 5. 3/4 times 5 is going to be greater than 3/4. 2 times 5 is going to be greater than 2. And 7/5 times 5 is going to be greater than 7/5. All right. 3/4, I want it to be less than 3/4, less than 2, and less than 7/5. Since I want it to be less, my scaling factor, which is what they're asking me to put in the blank, my scaling factor has to be less than 1. So any fraction will work. I'm just going to put 1/2. 1/2. 1/2. When your sign is greater, your scaling factor has to be greater than 1. When your sign is less, your scaling factor has to be less than 1. If it's equal, it has to be exactly 1. All right, let's look at the word problems. Johnny says multiplication always makes numbers bigger. Explain to Johnny why this isn't true. Give more than one example to help Johnny understand. So I would explain to Johnny, it matters what your scaling factor factor is. If your scaling factor is greater than 1, your product gets bigger. Example. Now I'm just going to make one up. Actually, I don't have to make one up. I could use this. 2 times 5 is greater than 2. However, if your scaling factor is less than 1, your product gets smaller. Example, 2 times 1/5 is less than 2. So it matters what you're comparing it to and what your scaling factor is. A company uses a sketch to plan an advertisement on the side of a building. The lettering on the sketch is 3/4 inch tall. In the actual advertisement, the letters must be 34 times as tall. How tall will the letters be on the building? So we're going to multiply 3/4 times 34. We're going to put a 1 on it. I can't multiply 3 times 34 in my head, so I'm going to come over here and do it to the side. That's 12, 9, 10. 102/4. That is an improper fraction, so I'm going to divide 102 by 4. 2, that's 5. Remainder 2, so that is 25 2/4, which is the same thing as 25.5. So the letters on the building would be 25.5 inches tall. Number 7, Jason is drawing the floor plan of his bedroom. He is drawing everything with dimensions that are 1/12 of the actual size. That's his scaling factor. His bed measures 6 feet by 3 feet, and the room measures 14 feet by 16 feet. What are the dimensions of his bed and his room in his drawing? These are the actual dimensions, but we're going to scale them down. So we're going to multiply 6 times 1/12, 3 times 1/12, 14 times 1/12, and 16 times 1/12. Going to put a 1 under all of them. 6, that would be 6/12, which is the same thing as 1/2. That would be 3/12, which is the same thing as 1/4. That would be 14/12, which is the same thing as 1 2/12, or 1 1/6. And that would be 16/12, which is the same thing as 1 4/12, or 1 1/3. So the dimensions of his bed are 1/2 times 1/4, and the dimensions of his room are 1 1/6 by 1 1/3. Dimensions are the measurements. Those are the measurements scaled down from his original dimensions to his drawing, because he could not actually take something that was 6 feet long and draw it on a piece of paper. It wouldn't fit. Now, you might want to pause the video here and do side 22 on the homework side so that it's fresh in your brain, and then unpause the video to look at lesson 23 problem set. Or you can go on to lesson 23 problem set and do the homework sides at the same time. Your decision. Fill in the blank using one of the following scaling factors to make each number sentence true. This says equal. I want it to be equal to 3/4. I have to use 1. Anything times 1 is that same number. This is a greater than sign. I want it to be greater than 21 hundredths, then I have to use something greater than 1. 1 and 21 thousandths is greater than 1. This says less. I have to use a scaling factor that's less than 1. So 989 thousandths is less than 1. The next one, you are sorting to tell if the product is going to be less than the box number or greater than the box number. So you don't actually have to work these out. If you want to know if it's going to be greater or less than this box number, you're going to look at what's not in the box, because what's not in the box is your scaling factor. This scaling factor is greater than 1. I'm going to put it in the greater than side. 13.89 times 1 and 4 thousandths. My scaling factor is less than 1. My scaling factor is what's not in the box. So this is going to be less than 3/10. Clear decimal there. My scaling factor is what's not in the box. My scaling factor is less than 1, so my product is going to be less than 602. My scaling factor is what's not in the box. My scaling factor is greater than 1, so this is going to be greater than 72 hundredths. My scaling factor is what's not in the box. My scaling factor is greater than 1, so it's going to be greater than 102 3/100. And finally, my scaling factor is what's not in the box. My scaling factor is less than 1, so the product is going to be less than 2/10. You get to skip part B, so we're moving on to number 3. You have to tell if it's going to be slightly more, a lot more, slightly less, or a lot less if your product is going to be more than what it says. So we're comparing. We want to know if it's going to be greater or less than 4. Here we want to know if it's going to be greater or less than 8/10. Here we want to know if it's going to be greater or less than 1,725. Here we want to know if it's going to be greater or less than 1 3/100. And here we want to know if it's going to be greater or less than 2 thousandths. So what is not highlighted is my scaling factor. So I'm going to look at what is not the scaling factor, and I'm going to determine if what's not the scaling factor is greater or less than 1. This is less than 1. Okay, now is it slightly less than 1 or a lot less than 1? 988 thousandths, that's slightly less. So is slightly less than. 4 times 988 thousandths is slightly less than 4 when I multiply it out. We don't have to multiply it out because we know how to look at the scaling factor. My scaling factor is what's not highlighted. It's greater than 1. Is it a lot greater or a little greater? It's a little greater. So is slightly greater than. My scaling factor is what's not highlighted. That is less than 1. Is it a lot less or slightly less? That's a lot less than 1. So is a lot less than. My scaling factor is what's not highlighted. 989 1 thousandths. That's greater than 1, and it's a lot greater than 1. Is a lot more than. All right, my scaling factor is what's not highlighted. My scaling factor is 911 thousandths. It's less than 1, and it's slightly less. Is slightly less than. So you highlight the factor you're comparing it to, and your scaling factor is what's not highlighted. Your scaling factor is what gives you your answer if it's going to be greater or less than the highlighted number. I love this question. During science class, Tio, Carson, and Dekeer measure the length of their bean sprouts. Carson's sprout is 9/10 times the length of Tio's, and Dekeer's is 1 800 times the length of Tio's. Whose bean sprout is the longest, shortest? Explain your reasoning. So, whose is the, let's go shortest first. The shortest is, do you know? The shortest is Carson's. Carson's is the shortest because his scaling factor is less than 1 of Tio's. So Carson's is the shortest because 9/10 is less than 1. And then Dekeer's would be the longest, is the longest. Oops, I spelled longest wrong. Longest. Because 1 800 is greater than 1. So it doesn't matter what Tio's is. Carson's is going to be less than Tio's, and Dekeer's is going to be greater than Tio's. And Tio's is in the middle. You can skip number 5. It is crossed off. So you have to do lesson 23 and 22, the homework side. There is no video. There is no answer key. If you have questions, you can send me an email or you can ask me in office hours on Friday.